You are watching Atul Engineer TV. Welcome to Staad Pro Training Videos by Engineer Atul. Lesson 1.2 Method of Analysis. In this lesson we will discuss the classical hand calculation method of analysis. Structural engineer's job has become very challenging nowadays. Everyone around him, let it be architect or the client, they want quick analysis, reports and construction drawings within very short period. Because of boom in construction industry in current few years, everywhere around the world mega construction projects such as bridges, high-rise buildings, mega township projects, roads, infrastructure and substation and transmission line projects are coming up. Structural engineers are working on several projects simultaneously. In this scenario, software Staad Pro helps the structural engineers to increase the productivity and meet out the deadlines and milestones of the projects without compromising quality, code provisions, structural stability and safety of the structures. All the famous codes of the world have been incorporated in Staad Pro. Now let us have a quick look at the classical methods of hand calculation. Method of analysis. One of the most famous analysis methods to analyze continuous beams is moment distribution method, which is based on the concept of transferring the loads on the beams to the supports at their ends. Each support will take portion of the load according to its K. K is the stiffness factor, which equals A divided by L, as you can see, and L is constant per span. The only variable here is I, moment of inertia. I depends on the cross-section of the member. So, if you want to use this analysis method, you have to assume a cross-section for the spans of the continuous beam. More information on this method may be sought from the textbook Structural Analysis by author Aslam Kasimali. If you use moment distribution method to analyze a simple frame, it will work, but it will not be simple. And if you want to make the frame a little bit more complicated, for an example a simple 3D frame, this method falls short to accomplish the same agenda. Hence, a new more sophisticated method emerged, which depends fully on matrices. This method called stiffness matrix method. The main formula of this method is matrix P equals matrix K multiplied by matrix delta. The three matrices are as follows. P is the force matrix, which includes the forces acting on the whole structure and the reactions at the supports. This matrix is partially known, as the acting forces on the structures are already known from the different codes, like dead load, live load, wind load, etc., but the reactions are unknown. K is the stiffness factor matrix. K equals A/L, and all of these data either known or assumed. So this matrix is fully known. Delta is the displacement matrix. The displacements of supports are either all zeros, fixed support, or partially zeros, other supports, but the displacements of other nodes are unknown. So this matrix is partially known. With these three matrices presented as discussed above, the method will solve the system with ordinary matrix methods to get the unknowns. If we solved for the unknowns, the reactions will be known, hence shear and moment diagrams can be generated, and the displacement of the different nodes will be known, so the displacement and deflection shapes can be generated. More information on matrix methods of analysis may be sought from the textbook Matrix Analysis of Fermat Structures by author James M. Geer and William Weaver, Jr. This method was very hard to be calculated by hand as it needs more time than other methods, so it was abandoned until the emergence of computers. The different programming languages as Fortran revived the possibility to utilize this method, as the program will do all the tedious and lengthy procedures to solve for the system of matrices. Therefore, structural software adopted it as the method of analysis. Staad was one of the first software to do that. This concludes Lesson 1-1.2. Please watch next Lesson 1-1.3 for corporate and personal training. Contact on atulkumarengineer@gmail.com. Contact on mobile number in description below. Thanks for your attention. Subscribe and comment on YouTube/Atul Engineer TV. Visit again for more exciting videos.